Alright, looking at target 3.6 mastery learning objective. Find measures of angles formed by lines intersecting on, inside, or outside of a circle. Okay. So the first thing we have to look at is the definition of what a secant line is. And a secant line is a line that passes through a circle. Okay, so both of these are secant lines, and unlike a tangent, right, a tangent hits it only once. A secant goes through twice. As I go through here, right, I hit it at one point, and then I hit the circle at another point. So it completely passes through that circle. Okay, it doesn't have to pass through the center, but it just has to pass through twice. Okay. So the first theorem we're going to look at today is the secants/chords angles theorem. If two secants or chords intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So the measure of angle 1 is half of the two arcs that are like on either side of it. Because, right, we have vertical angles, right, so these are the same, so it doesn't really matter there. So you have to take both of these arcs, add them together, and cut them in half. Same thing for measure of angle 2. Right? This would also be the same angle. They're those vertical angles. And so I add up their intercepted arcs and cut them in half to find the measure of that angle. Alright, let's look at example 1. Alright, here's our x. So it's this angle and that angle that we're adding up, right? So the measure of the angle is equal to half of, I'm going to start by saying big arc plus small arc, because in our next theorem it matters. Right, this theorem it doesn't, but big arc plus small arc. Okay. So x equals 1/2. Our larger arc is 130 plus 84. Again, in this one, since it's addition, they're the same. In later problems, it's subtraction, so we gotta be careful. Okay. Our variable's over here, so I could just type this whole thing in my calculator at the same time. 130, 1/2 times 130 plus 84. And we get 107 degrees. Easy peasy lemon squeezy. Alright, this one's a little bit different because these are the two arcs we have here. So like a meeting in the middle, right, line through the right, we're actually would be given that angle. Right, I'm just going to put one of them there. But that's not the angle we're looking for. Oh my gosh, sorry guys, it's jumping around. But that y is not the angle we're looking for. However, we might need it in order to solve for x. So this is also a common situation you'd see. So I am going to solve for y first. So angle equals 1/2 big arc plus small arc. So our angle y equals 1/2 times 143 plus 75. So 1/2 times 143 plus 75 is 109. Now if I'm solving for x, we can still use all the same things I know. X and Y make a straight line, and a straight line is 180 degrees. So X plus Y is going to be 180 degrees. So X plus 109, right? And so then X equals 71 degrees. Okay. All right, looking at our last example for this type of problem, all right, now I'm solving for this arc instead of solving for the angle, but it's the same type of thing, right? The angle is equal to 1/2 times big arc plus small arc. So our angle we know is 110. Our big arc is X, and our small arc is 97. Okay. I can get rid of this 1/2 first by multiplying by 2. So 220 equals X plus 97. And then I'm just subtracting by 97. Which is 130 minus 7, I think 123 degrees. All right, so that's kind of the difference if you're solving for one of your arcs versus if you're solving for the angle. Okay, go ahead, turn the page. Our next one is when we have a secant and a tangent meeting. Okay, and they meet on the circle. So that last one was the point where they cross is inside the circle. Here, the point where they cross is on the circle, right? And what happens here is the measure of the angle is 1/2 the measure of that arc that it opens up to, right? If I want to find this one, same thing. It's 1/2 that angle, or that arc. Same thing here as in our last one. You might get things where, hey, look, this is 180 degrees total, right? Or the whole circle is 360. So there's all these different things you might have to do. Okay. So let's look at example 2. So we're looking for Q to P to R, so here's my X. Well, this is just the basic one. The angle equals 1/2 the arc, right? So these are just similar to inscribed angles. All right, easy enough, that's 74 degrees. Same thing with DEF, or similar with DEF, right? I'm looking for this, but I have this angle here, and this angle opens up to this arc. So that's the only thing I can solve for with that angle. So I'm going to do the same thing. Angle equals 1/2 times arc. I know my angle, 64, equals 1/2 the arc. So I'm going to multiply by 2. I guess I should put y here. The 1/2 and the 2 cancel each other out, so I have 128 degrees. Just gotta keep writing. Equals y. Now, if I look, this x plus the y, if I go the whole way, is a whole circle. So x plus 128 equals 360. That's 240. X equals 232 degrees, I believe. Okay. So that is our secant and tangent angle theorem, right? Meeting on the circle.